Hello everyone, myself Dishala, Assistant Professor in Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So the subject is Basic Civil Engineering. Today I am going to discuss about Introduction to Civil Engineering. The contents covered in this chapter are Introduction, Branches and Scope of Civil Engineering, Impact, Role of Civil Engineering, Units of Measurements, Unit Conversion for Length, Area and Volume. So starting with the introduction. What is civil engineering? Civil engineering is the branch of engineering which deals with the planning, designing, estimating, execution and maintenance of various structures. That structure are building, roads, railways, airports, dams, canal, tunnels, bridges, docks, harbors, water supply and sanitary unit. Basic knowledge of civil engineering is a must for any engineer of any discipline. For example, knowledge of civil engineering helps the mechanical or production engineer for laying the foundation for machinery. It also helps the electrical engineer for fixing the electrical poles in a straight line with the method of surveying and also for making the foundation for electrical power substation. So the knowledge of civil engineering is must for any engineer of any discipline. Moving towards the next topic, that is branches and scope of civil engineering. So the civil engineering comprises the following branches, that is surveying and leveling, building planning and construction, advanced construction, structural engineering, geotechnical engineering, water resource engineering, transportation engineering, environmental engineering, town planning, fluid mechanics, earthquake engineering, foundation engineering and quantity surveying. Starting with the first branch, surveying and leveling. Surveying is a very important branch because before starting any construction work of any structure, surveying of a land is necessary first of all. Surveying is the method of taking the measurement of the relative position of the point on, above or beneath the earth's surface so that the points may be represented on a map or a plan. Surveying deals with the linear measurement and angular measurement in a horizontal plan. Linear measurements are carried out with the use of tape and chain. Then angular measurements are carried out with the use of compass. Leveling deals with the measurement in a vertical plane. In leveling, vertical measurement or elevation of relative position of a point are found out and then contour maps can be prepared so as to know the ground profile of the earth's surface or a land on which any structure is to be built. As surveying is deal with the linear and angular measurement in a horizontal plane and leveling deals with the measurement in a vertical plane. Scope of surveying and leveling. Surveying is carried out for setting out of works and for preparing a map of a land. Leveling is carried out to measure levels and to prepare a contour maps. Second, building planning and construction. So, first of all, what is building planning? Building planning is the arrangement of various components or unit of a building in a systematic manner so as to form a meaningful and homogeneous structure to meet its functional purpose. So, main components of a buildings are foundation, footing, column, beam, masonry, doors, windows, stairs, floors, roofs, etc. Buildings are planned according to the fundamental principle of planning and bylaws of local municipal bodies. While planning a building, the functional requirement of a various part of the building is very important. The orientation of various units of a building with respect to sun and wind is a vital for minimum energy consumption. In a photograph, we can see a planning of a house. Construction engineering is the technology of constructing various building structures by the construction processes involving various construction works such as excavation, foundation, footing, masonry, concreting and finishing. Now, scope of building planning and construction. So, The scope of building planning is planning of a different unit according to their functional need, and the scope of construction engineering is to constructing a residential building, public building, industrial building, etc. Third, advanced construction. Advanced construction consists of a construction of a heavy structure, for example bridge, tunnel, dam. Construction of that type of heavy structures require the advanced techniques like pre-stress concreting, slip formwork, underwater concreting, premix concreting, mass concreting, pumping concrete, tower cranes, etc. Then large-scale earthwork in excavation needs various advanced equipment such as JCB, scrapers, drag line, power shovel, bulldozer, etc. So the scope of advanced construction is to construction of a heavy structures like bridge, dam, airport, harbors, port, tunnels, caissons, cofferdams, pile foundation, well foundation, etc. 4. Structural engineering. Structural engineering is a very important branch of civil engineering. It is a branch of engineering which deals with the planning and designing of structural member of the building such as column, beam, slab, footing, etc. It is a technique of working out of the dimension of the structural member according to the load on the structure to support the dead and live loads. It is also used to calculate the amount of steel required. Nowadays, various computer softwares like StatPro, Struts, ETABS, etc. are used for the structural analysis and design. The scope of structural engineering is to carry out structural design of the structure by selecting the type of material like concrete or steel and fixing the size and shape of the various structural components such as column, beam, slab, footing, etc. Geotechnical engineering. It is a branch of civil engineering which deals with the study of soil, its behavior on application of load, its application as an engineering material and design of proper foundation. When heavy load of the building structure is to be transmitted on an area of the ground, then prior to that civil engineer always keep interested to know and study the load bearing capacity of a soil. It is noted that soil mechanics is always related to the foundation engineering. Scope of geotechnical engineering are detailed soil investigation of appropriate design of foundation, determining the bearing capacity of soil, design and construction of various type of foundation, for example shallow and deep foundation. It helps for finding the thickness of various layer of pavement, characteristics of soil related to the permeability, compaction and consolidation. Water resource engineering. It is a branch of civil engineering which deals with measurement of water, utilization, distribution and development of a water resource for agriculture, municipal and power generation purpose. The water sources is developed by constructing a dam on a river or a stream to retain the water on one of its side. Groundwater storage can also be developed by constructing the percolation tank. Scope of water resource engineering. Development of water resources at the right place, construction and maintenance of dams, canals and regulatory works for the supply of water. It helps to study the design of different structures such as spillway, weirs and canals, development of the new techniques such as sprinkler irrigation and drip irrigation. Crop rotation can be done effectively. Transportation engineering. It is a branch of civil engineering which deals with planning, design, construction, development and maintenance of roadways, railways, airport, docks, harbors, tunnels, bridges, etc. In short, it is the technology by which a proper communication facility is planned, designed and constructed for easy transport of human beings and goods from one place to another. Scope of transportation engineering. Easy transportation of men, machines, animals, materials and goods can be made during the days of emergency. For example, wars, efficient and developed transportation system play a vital role for quick and easy transportation of soldier, food and ammunition. Environmental engineering. It is a branch of civil engineering which deals with water supply, disposal of wastewater from domestic and industrial use, and environmental pollution control. Scope of environmental engineering. For water supply, constructing a structure like water treatment plant, water distribution network, overhead tanks, underground tanks, etc. Sanitary engineering. Wastewater in the cities is carried away by networks of pipelines called as a sewers and treated to made harmless. Environmental pollution. The effect of pollution have been observed on human beings, plants, animals, and even building materials. Hence, it becomes more essential to control this pollution and protect human life. Town planning. Town planning means plan and control growth of the town by dividing the land of the town into different zones. For example, residential zone, commercial zone, industrial zone, etc. and regulating the building construction in these zones to provide a better environment for the people of the town. We can see in the photograph that residential building, park, then school are placed away from the industries and factories to get a better environment and pollution-free environment. Scope of town planning. Planning of the town by zoning of the land, planning road networks, planning services like water supply, drainage, electricity, preparing a master plan of a town. Fluid mechanics. It is a branch of civil engineering which deals with the study of behavior of the fluid such as liquid and gases. That fluid may be in a rest condition or in a motion. Fluid mechanics is divided into three categories: fluid static, fluid kinematics and fluid dynamics. Fluid static, which deals with the study and behavior of the fluid at a rest condition. Fluid kinematics, which deals with the study and behavior of a fluid in a motion but without considering the pressure forces. Fluid dynamics, which deals with the study and behavior of a fluid in a motion with consideration of pressure forces causing a motion. Scope of fluid mechanics. It helps in determine the flow of a fluid. Earthquake engineering. It is a branch of civil engineering which deals with the study of zones of probable seismic intensity upon the different area so that any preventive care can be taken against earthquake. During an earthquake, the ground may move horizontally in any direction and up and down, which shift the foundation correspondingly. Seismic force vary rapidly with time, therefore they impose a dynamic loading on a building. An earthquake map of India has been prepared by the Meteorological Department showing a zones liable to serve moderate and minor earthquake. Scope of earthquake engineering: analysis, design and construction of earthquake resisting structure, planning for seismic risk assessment and mitigation. Foundation engineering. It is a branch of civil engineering which deals with the study of design, construction, maintenance, renovation of footing, foundation wall, pile foundation and other structural member which act as a foundation of the structures. It is related with the knowledge and study of geotechnical engineering. So the scope of foundation engineering is to design and construction of a various type of foundation like simple footing, raft foundation, pile foundation and well foundation. Quantity surveying. It is a branch of civil engineering which deals with the study of measurement of the items of the construction and multiplies it by the present market rate so as to know the probable cost of the construction. Before starting any construction work of the structure such as building or a road or a bridge, etc., any structure, a civil engineer always requires to know the probable or a estimated cost of the construction to achieve the provision of the budget for the construction to be done. The scope of quantity surveying is to determine the probable cost of the construction. Next topic is impact. This topic is about how the infrastructure development affect the economy of a country. So first of all, what is infrastructure development? So it is a branch of civil engineering which deals with provision of good infrastructure facilities which help to develop the rapid growth of the particular area so as to give the more impact on the economy of a country. The good infrastructure facilities involves provision of good transportation facilities. It means roads, railways, ports, airports, etc. Provision of well-planned water supply distribution system. Provision of electric power. Provision of a proper drainage system. Provision of parks and playgrounds. Provision of landscaping within the area under development. Provision of proper telecommunication system. If all aspects are fulfilled, then there is a rapid development and growth of the area, which give the good impact on the economy of a country. GIDC, that is the Gujarat Industrial Development Corporation, provides the infrastructural facility at many places in Gujarat. For example, Hajira near Surat. Infrastructure is a key element for the progress of any nation. It shows the impact of infrastructure development on the economic growth of the country. Per capita income and gross domestic product are the major economic key factor for the development. Following tables show the per capita income and gross domestic product from 2006 to 7 to 2008-9. As we can see in the table, the per capita income is increases with the year, the gross domestic product are also increases. India has sustained rapid growth of gross domestic product for most of the last 2 decades, leading to rising per capita income and reduction absolute poverty. Per capita income is the average income of a resident of a country in a particular year. Gross domestic product at a market price is the value of fixed good and service at a prices prevailing in the market produced in the domestic part of the country during a given year. Role of civil engineering. For any type of project related to the basic civil engineering field, civil engineer has to perform the following role: to carry out surveying and leveling with survey instrument, to fix the center line of roads, canals, railways, tunnels, etc., to carry out detailed soil investigation, to plan building according to the bylaws of local authorities and get construction approval from municipal authorities, to carry out structural analysis and design of a civil engineering structures, to carry out quantity survey and to prepare a estimate, to invite tenders and to select the contractor for the execution of the work, to supervise the work during execution, to ensure the progress of the work, to control the quality of work, to take the measurements and prepare a bills, to carry out testing of civil engineering materials, to carry out design, construction and maintenance of water treatment plants, sewage treatment plants, water supply and drainage line, etc., to carry out valuation of land of a building for the purpose of sale or buy, to act as an attributor in case of dispute between contractor and client. Units of measurement. Unit is a standard of measurement of a physical quantity. For example, mass of a body is 10 kg, means 10 is a numerical number and kilogram is a unit of mass. There are two units of measurement. First one is basic unit, or it is also called as a fundamental units, and second one is derived unit. Basic unit, that is the length, mass and time, are the fundamental physical quantity. The unit of measurement for these three quantities are called as a basic unit or fundamental unit. It is independent unit. Derived unit, when the units used for the measurement of the physical quantities from the use of basic unit of measurement like length, mass and time, is called as a derived unit. It is also defined as a unit which depend upon the fundamental unit. System of unit. Basically there are four system of unit: FPS, CGS, MKS and SI. Starting with the FPS. In this unit, length is measured in foot, mass is measured in pound and time is measured in second. Second one is CGS. In this unit, length is measured in centimeter, mass is measured in gram and time is measured in second. Third one, that is MKS. In this unit, length is measured in meter, mass is measured in kilogram and time is measured in second. Fourth one is SI. It is an international system of unit and adopted at a present by the countries with a maximum majority. Basic or fundamental SI unit of the physical quantity. For basic SI unit, length, mass and time are the physical quantities. Length SI unit is meter or millimeter and it is denoted as symbol M or mm. For mass, SI unit is kilogram and it is denoted as symbol kg. For time, the SI unit is second and it is denoted as symbol S. For a derived quantity, for force, SI unit is Newton and it is denoted as symbol N. For weight, also it is denoted as symbol N and its SI unit is Newton. For a area, SI unit is square meter and its symbol is meter square. For the volume, SI unit is cubic meter. Velocity, SI unit is meter per second. Acceleration, SI unit is meter per second squared. Angular velocity, SI unit is radian per second. Angular acceleration, SI unit is radian per second square. Density, SI unit is kilogram per cubic meter. Work or energy, SI unit is joule or Newton meter. Moment of force, SI unit is Newton meter. Momentum, SI unit is kilogram meter per second. Temperature, SI unit is degree Celsius. Power, SI unit is watt or joule per second. Unit conversion for length, area and volume. For the length, 1 mm is equal to 0.1 centimeter and in meter it is 0.001 meter. 1 centimeter is equal to 10 mm and 0.01 meter. 1 meter is equal to 1000 mm and 100 centimeter. 1 kilometer is equal to 1000 meter. For the area, 1 mm square is equal to 0.01 centimeter square is equal to 10 raised to minus 6 meter square. 1 centimeter square is equal to 100 mm square is equal to 10 raised to minus 4 meter square. 1 meter square is equal to 10 raised to 16 mm square and 10 raised to 4 centimeter square. 1 kilometer square is equal to 10 raised to 6 meter square. For the volume, 1 mm cube is equal to 0.001 centimeter cube and 10 raised to minus 9 meter cube. 1 centimeter cube is equal to 10 raised to 3 mm cube is equal to 10 raised to minus 6 meter cube. 1 meter cube is equal to 10 raised to 9 mm cube and 10 raised to 6 centimeter cube. Thank you.